right, and it's all yours.
All right. Thank you, Oliver. Good afternoon, everybody. As Oliver said, my name's Jeff, or Jeffrey Jones. I'm the regional sales manager for the Southeast, covering the states of Tennessee, Mississippi, Alabama, Georgia, the Carolinas, Florida, and Puerto Rico. I've been with DENSO since 1993. In working within the robotics group since 2010. So I have about 10 years working directly with the DENSO Robotics sales teams. But I have experience of integrating our product since 1993. What I want to talk about this afternoon is just the basics. It's not going to be an in-depth discussion about how to build a robot, or step by step. It's just going to be like an overview of how it can be done to build a robot or an XY slide, XYZ, whatever you're looking at, and using our what we call our MC8 controller. So the objective is the introduction of our MC8 controller and how you can use the Kinematics configuration tool that is provided in the WinCaps 3 software to control your robot that you design. For those who don't know who DENSO is, we're just not robotics. DENSO is a $50 billion a year company manufacturing automotive parts. We're one of the largest automotive part manufacturers in the world. We're also one of the largest robot users in the world, with over 27,000 robots manufacturing parts in our own manufacturing facilities. We have 2,660 different production lines across the globe in 150 different plants. Overall, including our own factories, we have over 143,000 robots deployed worldwide. DENSO has been making robots since 1967, so we're going into our 53rd year. It's a pretty good achievement. Our products are really good. We've had some revisions through the years, mainly on our robot controllers, but that is a little bit of who DENSO is as a whole. The agenda I want to look at is going to be going over just an overview of, like I said, overview of the MC8, MC8A. And the configuration system, what a configured MC8A looks like, and the Kinematics configuration tool. If you are familiar with our products and you're using any of our robots with the RC8A controller, you'll notice that the MC8A is basically the same controller. As I mentioned, it is the same as the controller is the same as our RC8A controller or our extended joint support controller. As usual, we like for people to look through the manuals, read the manuals, and when considering using the MC8A controller, you really should. There's a separate manual in our user manuals online, and you can see the link at the bottom of the screen. That's a link to go to our website in Japan and download the current version of the user manuals. The user manuals include a manual for each one of the robot types, a manual for the controller, a manual for the RC8 controller, I'm sorry, and then also a manual for the MC8 controller or extended axis, extra axis, And also on the Kinematics, there's a manual for the Kinematics configurator as well. But all of these manuals you'll find in the user manuals, and we do encourage people to read, even though they may be familiar with the RC8A, is to go through the other accompanying manuals for the MC8, as well as the extended joint manual. That will help you kind of get familiarized with what you're looking at as far as developing your own robot. The MC8 overview, it is a controller that controls the positioning of a user-supplied mechanism by using one of our servo motors. And an example would be to create just a custom XY slide. Or you could go up to XYZ, XYZT, up to 8 axes of motion the MC8 can control. The MC8A is functionally equivalent to our robot controllers, for the exception is you're not, when you order a robot and the robot comes with a controller, that controller is already specified for that particular robot. When you get an MC8, or when you order an MC8A controller, you're going to be ordering the controller and the motors and cabling, prospective cabling to go to to hook up to the controller. For the exception of you're not able to specify the robot arm type. And there are some commands that could cause unexpected movement when considering using the MC8 motion controller. Those being the CP motion, which is continuous path motion or linear motion. The tool movement, rotate command, your coordinate instruction, which would be the draw. Any palletizing, pallet command, and then as well as the approach and depart commands, and your free form move, which would be a spline motion. The MC8 is configured, as I said, can be configured up to 8 axes. Or you can configure it for a robot or a robot and extra axis. So what we have is the MC8 controller. The MC8 controller, like the RC8, it has 4 drive unit slots. And each slot is capable of running 2 axes of motion. So depending on how many axes you would be using, the controller would come in with either slot 1, 2, 3, or 4 occupied. Again, depending on how many axes that is in your design. Then you would select the appropriate motor and cabling. There's a motor and encoder, a motor cable, which is the yellow. Then you have the encoder cables, which are green, that go back to a central encoder hub. And that encoder hub then is fed back into the MC8A controller. Now, the system configuration and drive capacity. All of our, whether it's an MC8 or RC8A, MC8A, they all have a total drive capacity of 3,000 watts. And we do have a library, and that's combined of the 8 axes. And we do have a library of AC motors that are available, and they are specified once again in the user manuals under the extended joint manual. So the total drive capacity cannot change, even if you're using extended joints. The total is 3,000 watt max. Now, these are just a couple examples of a linear motion actuator or rotary motion. They're basically similar. There's things you need to take into consideration when designing these actuators. You need to know the ball screw pitch or the angle of rotation. You also need to take into consideration when sizing your motor and possibly gearboxes your payload, what your weight is that you're moving for each one of the axes. And these are all spelled out in the user manuals, and there's a specific section on how to design a servo mechanism. Also, as I mentioned in the manuals, there are a library of choosing your AC motors. We have from 30 watt up to 1,000-watt motors available, different flange sizes from 40-millimeter flange up to 100-millimeter flange. The motors can be configured with or without a brake. And in this same manual, you do have access to the PDF drawings of the manuals of the motors for the dimensions. They'll give you the flange size, bolt pitch, and then the shaft size. And once you have your system configured and you're ready to order it, and you order your MC8A controller, once you get the controller in, there'll be a tag on top of the controller that'll show how it is configured, what drives are going to which joints, and so on. The motor capacities, as I mentioned, are 30 watt up to 1,000 watt, and they are sized by the driver units that are available to drive the perspective motor in the slot that it's in. So these are the sizes of the driver units that would need to accompany the appropriate wattage motor. Now, getting into the Kinematics configuration tool. The Kinematics configuration tool, as I mentioned earlier, it is automatically installed when you install your WinCaps 3. So it's a free tool that is included with WinCaps. And with that configuration tool, you can take the MC8A series controller and configure a robot arm. Now, the robot arm would have to be prepared by the user using one of the motors that's in our library of motors that are available. You can go to a SCARA, you can build your own SCARA, your own Delta robot, or like a gantry robot, as well as a 6-axis robot. But we still need to use our motors. So the Kinematics configuration tool, as it comes with the software, with the WinCaps, is without license. Without license, what that allows you to do, out of the box standard, you can do the following configurations without license. And that would be configuring just an X joint, XY, XYZ, or XYZT. Those you can automatically configure without a license. Now, if you purchase a license, what the purchase license is going to allow you to do is get into the more detailed, I guess, robot arms, to include the Delta 3. It's a 3-axis parallel link robot or a 4-axis parallel link. It also gives you the ability to use a gantry, create your own gantry robot, or a SCARA robot, as well as 6-axis robots. In considering using these robot configurations with a license, there's some things you do need to take into consideration. There are additional arm lengths that need to be programmed into the parameters, and once again how to build a actuator in the user manuals that spells out what you need to do, what measurements you need to consider when entering into these parameters. Now, what I want to do is show you a configuration and that I created already offline using 4 axes. I'm actually using four different axes here. Let me run it just to show you what it's doing, and then this is all done in our simulation software that is within the WinCaps 3 programming software. So what this is doing, I have an XY, and I have my X-axis, Y-axis, my Z-axis up and down. And what I'm actually doing is using 2 extended axes for the gripper that is opening and closing. This all can be done within our WinCap software using the simulation and the ARM 3D view. So what I want to do is I'm going to stop it, reset the program, and just want to show you that I can go in and I can move each joint manually by the slider bars, and I've got limits set so it doesn't crash into one another in either direction, and then my Z-axis. Now, as I mentioned, I'm using J5 and J6 as external or extended axes. They're actually not configured into the Kinematics configuration tool. What I've done is we went out to a supplier and brought in CAD drawings of these linear actuators. And what I'll do is I'm going to attempt to try to simulate or show you how easy it is to bring in these 3D CAD drawings. And I'm just going to bring in the X and Y axis just to show you that it can be done and what we can do with it. So I've already started up my Kinematics configuration tool that you'll find in the tree wherever your WinCaps software is stored. So what I want to do is I'm going to create a new project, and I'm just going to name it XY in a test. So once I got my name in there, I next, robot type is MC8A, and it is a safety I/O controller. No other specifications I'm going to use. Next is going to let me close this window down and see if that helps. Seems to be running a little slow. Okay, all right. I'm going to exit out of my presentation for a minute. All right. So it brings you up to select robots, to select your robot shape. You have the option of selecting X, XY, XYZ, XYZT, SCARA, XR, and so on, as I explained earlier. What I want to do is just go in and show you how I can model in these images to make it look like an XY robot. So I'm going to select XY. There are no other settings that I need to take into consideration at this time. Everything will be set as in my parameters as far as the amount of motion I can have on each one of the axes. I'm going to go next. It's going to tell me what I'm selecting. Next, and then open the project in WinCaps. It's going to complete. Wait for it to open. Loading the project. Now, up at the top, if I go to arm view, click on that. Normally, if you have a robot and controller package that you bought already, and you select the appropriate robot, a picture of the image of the robot would be populated in here. But what I want to do is be able to go in and add my 3D drawings. And I'm going to go in and add it under the tool. I'm going to select tool 0. I'm going to go to, this is all done under model tree. I'm going to go to 3D. It's going to go out to my files and look for a what we call a VRL file, which is in my downloads. So the first thing I want to bring in, the drawings are in 2 pieces. The first thing I'm going to bring in is what's called the slide itself. So it's importing it now. Okay, we don't see it here. The reason it is because the scale is off when it's brought in. And you want to make sure when you take a CAD file and you convert it over to a VRML file, you want to make sure that you're doing it in millimeters. But right now the scale is 1:1, so I'm going to enlarge this scale to a point to where I can actually see the image. Boom, there's my slide, my linear actuator. Okay, now the second part that I'm going to bring in, that I want to bring in, I want to make sure, I want to go back up to my tool and I want to make sure that I attach the second drawing to where the first one is located. So I want to make sure I'm highlighted on my slide and then go back to 3D, back to my downloads. And I'm going to bring in what is called the truck or the carriage. It's importing it now. Once again, I'm going to have to go in and size it. Right now, you can't see it because the scale is still 1. I'm going to size it accordingly to the slide. And now I have my carriage or what's called the truck. Now, if you look, if I zoom in on it, you can kind of see that the carriage is hitting the housing of where the motor's attached. So I need to put an offset in there to bring it out so it doesn't hit that. And I'm going to bring it out into the negative Y direction. Not 750, it should be 75, sorry. A slight typo, negative 75. And I'm just using the values that I used on my my simulation that I showed you, so I don't have to go back in and try to figure out where it is. But so I give it an offset of negative 75, which brought it well within the travel range and not crashing into the motor housing. So now what what's simple about this process is I want to duplicate this. I'm going to use the same size slide, the same size truck and carriage. So what I can do is go up here to my arm, and I can copy that. I can copy it, and then what I can do is go back and put it, and I want it to attach to the truck. So it's going to, if I click on truck and then paste, it's going to paste it on top. Well, actually, it's inside. So now what I need to do is turn the second one 90 degrees to the first slide. So I want to make sure that I select the one I want to rotate, and I need to bring it up like 90 millimeters up, and then I'm going to do a rotate about Z at 90, and there. So now I have this slide attached to this truck, and now I got to adjust my second truck so it doesn't, if we mount anything off to the side, down, so it doesn't crash in when it comes back to full stroke. It doesn't crash into the other slide. So I'm going to put an offset in here of a negative 150 to move that truck out a little bit. Okay. Now I'm going to go back to my first truck here on this axis, and now I got to assign a joint to it. So I'm going to come down here to property. I'm going to go to J1 and change it to a y-axis, and now it should be connected to J2 or J1. I'm sorry. So now my second truck, what I want to do is highlight it. And then I want to also go in and connect it to a joint 2 at Y. Right now I have those connected and attached to a joint. Now I have to go in and enable my joint. So I need to go to my project, and I need to go to joint setting table. In my joint setting table, you'll see joint setting, arm group setting, link info setting, and select robot joint. I want to show you the selecting robot joint. Remember when I first started my Kinematics configurator, I told it to do an XY. What that done is automatically selected joints 1 and 2. If I was to do an XYZ, XYZT, it would select the corresponding one. Up to 4 joints. So if I would have done an XYZ, it would have been joint 1 to 3, XYZT, joint 1 to 4. So I'm good to go. I'm in joint 1 and 2. I need to go back to my joint settings, and I need to change my positive and my negative motion limits, because right now the limits are opposite of what the slides are set in as. So both of my positive motions for both joints is going to be set to 0. My negative motion for J1 is going to be negative 500 or negative 500. I'm sorry, negative 500. And then joint 2 is going to be negative 450. So now, if you look over here, my joints, none of my joints are enabled in my slider bars. I've got to go in and tell it to enable the joint, which allows me to do the joint motion. So I need to go in and turn J1 and 2 on. And once I clicked OK, it's going to enable my joints. So now I can come over here and I can slide the joints back and the J1 back and forth and J2. So it's pretty simple to do. we can bring these CAD drawings in a, as I mentioned, a VRML file or a DirectX file, and you just need to size it accordingly, and then locate it in a position. And you can also work around your complete assembly, machine assembly CAD drawing as well to lay these units in. So it's pretty simple to do. You just got to do some planning up front, sizing the motors correctly, and so on. So with that being said, Oliver, I think that is, let me go back to my presentation, but I think that is it. Let me start from current slide. So, and as Oliver said at the beginning, look for future webinars at our DensoRobotics.com website. They will be posted hopefully in a couple weeks for the June webinars. With that being said, Oliver, that's all I have. Unless there's questions that I need to try to answer.